And I've begun recording the meeting. Now I shall share screen. Let's see. It doesn't seem to allow me to share my whole screen, just a single application, so that will have to do. Welcome to EMP Hackathon Advanced, brought to you by this default PowerPoint format that I actually like a lot. It's a great format. It's very aesthetically pleasing. So here's a table of contents, just the stuff we're going to be going over. I know it's classes, data structures, files, and a little bit of graphics. I won't really get into graphics that much. And here is a file. You can't see it here, but if you go into the Google Drives, you should be able to download both the PowerPoint and the files. And I see something in the chat, so I can't. Inheritance is tough for me. Okay, well, we're going to be going over that a little bit. And if you have any specific questions, just be sure to ask. If anyone wants me to take a moment to stop so you can download these files or whatever, just tell me. I'll be moving on now. You don't have to follow along or anything for this class, but definitely could be something you can mess with outside of class. So here's basically some useful uses and notes before we actually get into the coding. The most obvious thing is that if you're struggling with something, just look it up. It's not uncommon to just not know how to do how to handle a particular class, or just forget how to do something, and it's all online. Especially if you're trying to look for a pre-written class to handle something like maybe a Rail file type, something that I had to deal with over the summer myself with Python rather than Java. I had to handle a really weird file type called nii.gz file. It was a medical imaging file type, and I was just able to find a class written by someone else that was able to read those files and render them in 3D, which is pretty nice. So yeah, if you are struggling with something, or if you have some kind of weird problem you want solved, such as a weird file type, or maybe you want to do a directory search or something, then you can just look it up, and chances are someone who has made something that some tool that will make your life a little bit easier. You don't have to make everything from scratch. There's multiple correct ways to do basically everything. And when you're debugging, there's a lot of different strategies. You can use print statements strategically placed to give you output information. I'm sure you guys are familiar with this method. You can look up the error you're having, mentioning the name of classes, the exception message, and all that. And usually there's a nice, helpful Stack Overflow or occasionally Chorus thread. And you can also use debug mode if that's something you're familiar with. Here's just some general sites that I reference a lot. And you guys can all email me if you have any questions related to Java, or if you had a question in class that I couldn't answer on the spot. Just send me an email and I'll figure it out, and I'll reply as soon as possible. Try not to sound so dead inside. And making sure this is recording. I believe it is. I'd be really sad if it isn't. On object and classes, this should be a review. You guys should probably know what an object and a class is. But basically, a class is a blueprint that's used to make objects. And a class can have attributes and methods. Attributes are basically the variables inside, the stuff it has, and the methods are the things it does. So for example, if you had a class that is modeling a COVID-19 patient, you might have attributes such as their name, their risk of being infected, etc. And with methods, you might have a method to calculate the risk of infection in a specific event, or a method of printing out the information or something like that, right? And a special type of method are constructors, which are methods for initializing objects. And when you're trying to initialize an object over here in your main or wherever else, you would have to call this constructor and pass in these arguments. Here we have you passing in a name, an age, and 3 Boolean values that are saved here. And again, example code is there, and you should be able to see that. And I'm going to switch really fast to my Eclipse workspace. This is the COVID model person code. It's again available in the PowerPoint, and as you can see, you have a number of different methods: public, private. Most of them are fairly simple, and this is not medically accurate or a fully functioning demonstration, but it's a simple little class for modeling a COVID-19 patient. I'm sure that at least a couple of people in this hackathon are actually going to make some kind of model or some kind of epidemiology model. So this might be similar to a class you would actually make for a simulation of some kind. And here we have a couple of demonstrations of this method. And I won't go over this in too much detail because, again, this should be fairly self-explanatory code. And again, if you see anything you don't get, then just send a message in chat or say it out loud, send a question. But yeah, I have some basic two-string methods that print out information. I can print out calculations of infection risk based on whether or not they're wearing a mask or social distancing. And I can use the vaccinate function to change someone from not vaccinated to vaccinated, which also decreases the infection risk. See, this is some really intelligent simulation creation right here. So yeah, there's a number of different functions in this miniature method here. Anyways, we're going to go back to PowerPoint. So most important thing to consider with classes is when you want to use them. You want to consider what you actually want to model, and you want to consider how you want to model that. So for example, you might want to model sprites in a game. You might want to model like a potential disease vector like we just saw. And generally, it's just a really useful way of grouping connected information or connected behavior. So classes are pretty useful when you want to make code easier to understand and easier to use. Now we're going on to inheritance and abstraction. So first, inheritance, I hope I'm pronouncing that right, is basically use of parent classes and child classes or sub-super classes. I have a chat message. How do you make a class? Okay, so it's probably a good idea for you to go look at my example code from the previous slide. So I got a Discord notification, but I can't check that right now because I'm busy doing this. But this is an example of a class. So you have public class, that header. You have your attributes, which are just like these random variables you have saved. You have your constructor, which is this special method for creating instances of objects, instances of the class. And then you have some other methods that the class does. But the most basic, this is a really, really basic class that I have saved. And you have the attributes, you have the constructor, you don't have any additional methods, and you just have the name. So this is an example of a super basic class. It doesn't really do much, but it's a class. And if you want to make one, you just right-click new class, and you can name it pumpkin or whatever, right? And you would make a constructor. So public pumpkin. What is misspelled? And like you can add some names or whatever else you want to say here. So that's how you make a class. I know that's really fast. Chat. What does the this do? That is a good question. So the this is a keyword that shows that that essentially refers to the current version, the in-class version of a variable. And the reason for this is that, get it, is that you see how like the variable name of the argument being passed in, the variable name is the same as name here. And so we have two variables that both have the same name. Or like with age, these are both named age. So that gets kind of confusing because the computer doesn't know when you say age whether you're referring to this argument you're passing in or whether you're referring to this age that's saved in the class. And so the way to resolve that is they use this keyword to signify that you are referring to this class's version of the name variable or of the age variable. And as you can see, if they don't share a name, such as is high risk and high risk, you don't need to use this keyword. And this keyword is also used to call methods within the same class, among other uses. Yeah, it is pretty useful. There's a similar keyword called super that we're going to talk about in a second. As you can see, this .check high risk is calling its own class check high risk, which simply checks if someone is above 65 years of age, in which case they will set that the person's high risk status to true based on their age. So that's like a potential use of that. Again, if you have questions, please continue asking them, and I'll try to respond as much as I can. So inheritance, you can make subclasses and superclasses, and that basically you use a keyword called extends. So for example, if you're making a class pumpkin, you can say public class pumpkin extends vegetable, or dog extends animal, and that means this parent class called vegetable that you are kind of making a subcategory of. It's important to know that child class can only have one parent class, so you can't extend multiple parent classes. And the keyword super is used for constructors. So when you're calling a method in the parent class, or if you're using a variable stored in the parent class, you would use a super keyword, similarly to how you use this keyword in within a class. And I'll show this in a second so it'll make more sense. Parent classes, they might seem a little bit pointless at first because you're not sure, like, why would you even use this, right? But they're actually pretty useful because you can use them to avoid having to write redundant code. If you have a bunch of, say, like vehicles, and both cars and trucks have to be able to, track their mileage and honk, or like, whatever other methods and attributes they might have. They share a lot of methods and attributes, so it will make sense to group them under one parent class, so you don't need to keep writing that code over and over again if they're just going to do the same thing. It also allows for compatibility with other classes. This is something you would see a lot in the Java provided libraries, where you have like another class that's designed to take in a parameter that is, like, for example, anything in the writer class, and that could include any of the subclasses such as buffered writer, actually not buffered writer, but such as, I don't know, print writer. What's another writer? I can't come up with examples, but I can't think of an example. Pass writer, buffered writer, print writer, but anything that's within that class can be passed in. So basically allows more compatibility, because if it's compatible with a parent class, it is compatible with this subclass. And it also just allows for clearer organization, so your code becomes more readable, and you can organize stuff into categories that make sense, such as organizing dogs into animals. I hope I don't sound too dead inside when I'm talking. And this is abstraction. So this is basically making abstract classes or interfaces, which are two separate concepts. An abstract class is really similar to just a parent class. It is a parent class essentially, but it's a little bit different because it's abstract, and that means it doesn't have fully defined methods and variables, and therefore you can't actually create an object from an abstract class. It's abstract. I'm repeating myself a lot. And just like with normal classes, you can only extend one, so you can only have one parent class. It could be abstract or it could be not. And you cannot make objects that come from it. I have a chat message. Do you have an example for inheritance? Yes, I do. I'll be looking at an example of both in a second. I'm just going to talk about this first. this is interfaces is really similar to abstract classes, but interfaces are not actually a class at all, and you also can't make objects from them. You use the keyword implement rather than extend, and a really cool thing is that you can implement multiple interfaces, whereas you can only extend one abstract class or a non-abstract class, any class. You can also extend one class at max and then implement as many interfaces as you want. However, interfaces do come with some restrictions that I won't get into too much here. Generally, the rule between using an abstract class and interface is that an abstract class defines what something is, whereas an interface defines its functionality. And we'll see that in a second with this piece of code, which is my FDA-approved medicine and antibiotic. As you can see, I am attempting to focus on healthcare-related topics. And allow me to simply uncomment out my second slide code. And I'm going to remove the pumpkin. Sorry about the pumpkin. So here I have an example of an interface. This is in a very basic interface, and basically all I have is a Boolean method. So this is not a variable. This is a method called FDA test, and that basically it requires that this the class what's the word? I just forgot the key. Okay, it requires the class that's implementing the interface actually implements both of these methods here. So it has a method to test if this medicine is approved by the FDA, and it has a method that prints out a certificate from the FDA. And it's an example of interface being used for what a class does. And here is a medicine class, and this is not an abstract class. This is just a regular parent class. And you can tell it's not abstract because it has these fully defined out methods, whereas with an abstract class, you would see something more similar to an interface, although a little bit different format, where you don't really have all these defined out methods. So here you have your normal attributes, methods, and all that stuff, and you can look at this in more detail in your version of the example code if you like later. Now I have this antibiotic, which is the class that extends medicine. Again, that means that it's the child class of medicine or the subclass of medicine, and it implements FDA approved, which means that it's implementing FDA approved the interface. Again, you can have as many interfaces as you want, but you only have one parent class. And so this antibiotic has some attributes. These are just biology terms. Biology, yeah. And it just measures the effectiveness of the antibiotic against two types of bacteria. Here's a constructor, very basic. And as you can see, here's the super keyword I mentioned. It's a little bit similar to the this keyword, but here we're using the super keyword to call the constructor in our parent class. And this may be a little bit confusing, but think about it basically as you're giving this, when you're making this antibiotic, you're giving it a bunch of information, and some of the information is saved into the antibiotic, whereas some of it is just a general medicine features, medicine attributes such as name and side effects and whatever, right? And so you would just pass that on upwards into the super class, therefore super, and give it to their constructor right here, and that will be saved into these attributes. Hopefully that makes sense to you. It's not that complicated, hopefully. But as you can see, we needed to implement these two methods as deemed by the interface, because you have to implement these methods. If you don't, there will be an error. So I've implemented an FDA test, where hypothetically you perform a test to determine whether this antibiotic has been approved. I don't really have a code to simulate this, and I figured it would be kind of pointless. So for now, it's just returning true because it's just always being approved. And here with the certificate, you can see that if this.fda test, so it would call its own method to see if it's been approved. If it's true, then they'll print out that it has been approved. But if it's false, they'll say, hey, this hasn't been approved. This is possibly dangerous. And I'll give you a warning. So this is an example of the use of both an interface and a parent class. So let's try to run this. It creates a new antibiotic that is called Tigasil, and it's a real antibiotic. It calls a couple of different methods I made, just like some random division methods. And crucially, it calls this FDA certificate method, and as you can see, it hasn't been approved. And once again, emphasize that the methods in the parent class, you do not have to implement in your child class, but you can if you want to. So if I don't, so if I want to like edit this somehow, I can actually just create a new method named public string side effects and basically override the one in the parent class. I think. I hope I'm not remembering something wrong. And that is called polymorphism. Good. And I'm going to pop back into here. So now we have a picture of cats. There's no reason for the picture of cats, but it is extremely important to the content of this lecture. I'm observing a moment of silence for the cats. Okay. Now let's look at some data structures. So here's some useful data structures. It's really simple. They're just 4 really common ones. This is the array. It's inbuilt. I'm sure you all know how to use an array. And you can find length, the dot length. You can access through indexes, and you can't adjust the size of the array, which is one of the biggest limitations of the array. An array list, which is very similar to a related data structure linked list, can be created in this kind of format. Array list string equals my array list new array list string. And there's some variation you can use in the formatting here, but that's the basic of it. You can find the length of an array list with dot size, note the parentheses, and you can add new strings with dot add while passing in your string parameter. You can adjust the size of the array list just by adding on to it. And it's very similar to linked list, which is just a related data type that basically has the same functionality, but it is different in terms of its efficiency at various tasks. Generally with small data sets, just err towards array list. And this isn't something you have to worry about unless you're handling a lot of data and speed is a really big concern for you, in which case you want to look into exactly what the benefits of each data type are and determine which is going to be better for your specific application. But yeah, it's really not a big deal if you're just doing your small stuff. For array lists, something important that's different from arrays is that you need to use these things called wrapper classes. What is a linked list? So a linked list is a data structure like an array list. And if you want to make a linked list, it's also another type of list. It's an object. Okay, so like you see how like the array list is an object that you can make. A linked list is also an object. It's just a different one that I didn't choose to talk about because I didn't think it was as important. And I think it was similar enough that it doesn't really matter, basically. It's just another object. Just another class. So this is an array list. You can use that. And you have to use wrapper classes, which basically means, and you have to use the word capital letter integer instead of just int, and boolean instead of boolean when you are declaring this array list. And that's because this doesn't accept primitives, which are these ints and booleans. They're primitives. They don't accept primitives. They need the wrapper class object, which is why you use that. And that's a really helpful feature Java has provided. There's also a hash map. It's similar to the tree map, which again is just another type of data structure / class provided by Java. And a hash map is different from an array list and array in the sense that it actually doesn't have an index. It has a key and a value. So for example, your key is a name and your value is an age. So you have a string integer hash map and you have key value entries. Something that's really important is that you cannot have duplicate keys. So you can't have two people named Helena. That's my name, by the way, that are both different ages, because it won't accept that. So if that's the case, you might want to consider including last names. However, you can have duplicate values, so you can have multiple people that are both 16 years old. This makes sense, logically speaking, because it would be kind of ridiculous if you can only have one 16-year-old. And this is just a different data format. And the reason you might want to use this is maybe you maybe just want to save data that only makes sense to be saved in a hash map. Like, it wouldn't really make sense if you want to save data of, a list of students with their ages or countries with their capitals in a ordered array list. Like, that doesn't really make sense. So you would use a data structure like this. Some special functions to take note of are key set, which gives you a set of the keys. A set is just a collection. Is a collection of the keys. And what's important about a set is that it doesn't allow any duplication, which we'll discuss in a second. And that's really and that's reflecting of how the keys in the hash map do not allow duplication. So you can only have one person named Helena, as I mentioned. And dot values gives you a collection of the values, and you can have duplicate values. I'll demonstrate this in a second. I know it might be a little bit confusing. And finally, let's talk about a hash set. So it's really some of the tree set. Again, just a related object. And a hash set is like basically a list that not a list. Sorry, a hash set is a collection of strings or other objects, right? That does not have any duplication. So it does not have duplicate values. So, like, for example, if you have a list of brands, you would not have Coca-Cola twice. You can only have it once. And if you keep trying to add a new one, it will just not add in a duplicate. You can only have one of each unique value. Hi, Vincent. It's nice to see you. I like your background. Do you have a comment or a complaint to make?
No.
No? Okay. I don't know if I said something wrong. You should tell me. But I'll switch to my clips now. So, as you can see over here in my hackathon main, I will demonstrate the coolness of a useful data structure. Yay. And let's see, why is there an error? New set. Oh, I've got to delete this. That's just junk code. Okay, I do apologize if you see that line of code in your code. You can just delete that. I was messing around. Okay, suppose we have arrays. They're really simple. You can create an array like this or like this. It's a lot of different formats, but you can make one and you know how to make one. You can find their length. You can set different values in the array, and you can use arrays.toString to print out a nice little array like this. If you just do this .toString directly, you will just get a nonsense series of letters and numbers, because it doesn't print out this. It prints out its like storage location, I think. Now we have array lists, and that's this series of print lines right here. As you can see with an array list, the size is not, I don't know why I called this without adding a print statement. The size is not set in stone like it is with an array. It's flexible. You can just add items. You can even remove items, and it's just flexible, right? You can loop through it with a for each loop, just like you can with an array. And so I'm demonstrating here with for every string in this list, just print out this is in my array list. As you can see, pineapple, eraser, and plate are all in my array list. You can also access based on index. You can also search .contains and all that stuff based on exactly what you want. Actually, Eclipse has a really helpful function for if you want to see what kind of things you can do with it. Right, you can see if it contains an object. For example, if it contains pineapple, then let's just see if it contains pineapple. And over here, you see that it prints true because it does contain pineapple. But meanwhile, if I say, does it contain banana? it would not contain bananas because it didn't add that to the list. This is false. So that's just some of the functions you can use with an array list. And to address the question, Olivia, a linked list would be a really similar kind of object. You can just make a linked list just like you can make an array list. Linked list. You can just use list. Integer. Maybe we do a list of integers. Not integers. Integer. My linked list equals new linked list. And I didn't import linked list, but yeah. So this is an example of a linked list, and it would just be a really similar kind of structure. You can also add things, right? 1232, right? And you can also use most of the same functions as you can use in an array list, and that's why I said they're really similar. They're mostly different in terms of which things they can execute faster, which is why it matters for a large data set, but not for a small one. But yeah, that's a linked list. Hope that answers the question. And once again, we have a hash map. I'll probably speed up a little bit here, but you should notice that the for each loop looks a little bit weird with a hash map because, or use .put instead of .add, because you are looping through every string in the key set. So remember the key is the names or the strings. So Helena, John, and Amy are the keys. These are the ones that cannot duplicate. So I cannot put two people named Helena because it will simply just discard that first version of Helena because it can only save one. So key set, names, or the strings, and they cannot repeat. Meanwhile, values, see how this is not called value set? This is because it's not returning as a set because a set does not have duplicates, whereas values can have duplicates. Values are the ages or the integers here. It's the second object passed in when you're creating a hash map. And we have 16, 16, and 12 as our keys. So right now we're looking through every string S in our set of keys. 16 and 12 as our values. Every string S in a set of keys, and it will just print out this person in the hash map. And if you can see here, I printed this out. Helena's in my hash map, John, Amy, and those are all the people I added. If I print out if I print my set of keys, note that this is not an array, which is why I can print it out like this directly. You can get Helena, John, and Amy. If I print out my values, you can get 16, 16, and 12. And just to prove, right, I'm going to change this really fast and have another Helena add in. And as you can see, instead of adding in a new Helena that's 18 years old instead, it just deletes the first Helena and changes the age to 18. So they cannot be duplicates with the keys. If I change the name, and you can see that I can just add in a new person named Heather who is 18. That is a demonstration of this thing. And finally, about hash set, this is just like, hash set is just like if you have an array list, but you don't want order and you don't want duplicates. It might make sense in some situations if that's what you need for your data set. So, I don't know, if you're like keeping track of a list of names of bacteria or whatever, it might make sense to have a hash set. And you don't want to have duplicates saved into your hash set, so you need one of these. Yeah, it's pretty basic. There's nothing new to add here. It's just the same kind of data type that does something slightly different. And I'm going to comment this back out. And again, if I have been confusing or if you guys are confused by anything, just tell me, and I missed a chat message really fast. So .add to the Dia says, so .add to the array list as a whole. So yeah, .add will append a new thing at the end of the array list. So for example, you can add a string or whatever. And there's a lot of other methods, a lot of functions of an array list. You can, I believe you can add a specific, I can't do it now, but I believe you can add a specific location in the array list because they are indexed or something else like that, but .end just appends to the real end of it. And you can also remove certain entries and all that. Again, I'm not going to go into the really specific details of everything you can do with a specific class, but if you want to know that, you can just, the best resource for that is just going to the official documentation and taking a look at the things they have available, because they have it all listed out. Or we can literally just type out, we can literally just take one of these array lists, right, and you type out dot, wait, not this one, right, type out dot, and I'll give you like a list of all the things it can do. Some of these you probably never need, but right. Index of object O. If you want to see which index of specific object, such as pineapple, is at, you can use this, and it will return you the integer number of the index. So again, array lists are indexed. They're really similar to arrays. They're just cooler. They're better. They're not always better. It depends on the situation. That's not talking about data structures. Let's go into creating and writing in files, and soon after reading files. I don't have like additional example code attached because it's all my main. In my reading files, I have two files named patientinfo.txt and covidgenome.txt that are like attached here that I read with my reading file program. I'm going to slow down a little bit here because I do feel like fewer people might have experience with reading and creating and writing in files and reading them than they would have with data structures and with abstraction classes. And I do think that's a fairly important skill set. They no longer require you to be able to read and write files in USACO, but they did do that every year up until this one. And generally, it's just something that I've always thought was like cool to do in programming. I don't know why, but it's always been fun. So yeah, I'm going to code here. And here I'm going to demonstrate reading files or creating files first. Okay. Wait, I just realized I probably should have gone over the PowerPoint first. Duh. Creating and writing files. So we have, you can create a new file with file myFile equals new file at this path. So this creates a file object within your, Eclipse or whatever other thing you're using. But this doesn't actually create a file like inside your like Windows Explorer thing, right? Right, your file explorer. It will create an object you can use for the purposes of your program. And in order to create a blank file in the specified path in your Windows Explorer or your Files Explorer, right? You actually need to use myFile.createNewFile, which is just a function that will make a blank file at that location. Hello. What is the purpose of creating a file? I don't understand what happens. Okay, so creating a file, like here, let me just, okay. I will just share screen really fast to my File Explorer, share, right? Hopefully you guys can see this. These are files, right? For example, here's a text file of the COVID genome, or part of it, I mean, right? These are files, these things that you see in your computers. That's what we're talking about, right? Every time you make homework, you write some homework or whatever, it's in here. And so this kind of code will allow you to actually create and edit files in your computer. And this can be useful, like in the context of this kind of contest or this kind of hackathon. If you need to analyze, for example, a COVID genome file or some other large form of data from an outside source, often it becomes too unwieldy to just copy it into your code or something by hand. If the file is really large or really repetitive or requires some kind of parsing. And that's why you would want to be able to, say, access a text file directly in order to read the information that's in it with your code, automate it, and then save it into whatever data format you need to save it in. Hopefully I explained that well. Basically, it's pretty useful to be able to access these files. So with the project I did over the summer, actually, part of the thing I needed to do was I needed to download like large amounts of medical imaging data files from a host server site, and I downloaded so many files. I don't even know how many. It was just ridiculous. It was a ridiculous volume of data, but yeah, I had to. I definitely had to learn to use Python, not Java, but you learn to use Python to read and sort through numerous files. Anyways, here's how you create a file, and you can create a new file with no chat message. Okay, you can create a new file with this function, and to write in files, you can use. Why is this not? To write in files, you can use file writer, print writer, or another tool. This is what I was trying to talk about earlier that I messed up with, different types of writer. A buffer writer wraps on a writer and makes it faster. And I'll show you what this means in a second. So buffer writer is kind of like a thing to wrap around another class and just like buffers it and makes it better. So writer is actually an abstract class, which we talked about earlier, so that's pretty cool. And it's the parent class of print writer, buffer writer, and output stream writer. And in turn, output stream writer is the parent class of file writer. So as you can see, the Java libraries have a lot of these nested layers of parent and child classes and abstract classes and interfaces. And remember what I said earlier about abstract classes making classes compatible with others. So this is a good example. If you have some kind of program that some kind of class is written to accept any kind of writer, for example, a buffered writer, right? You need to pass in a writer, right? And that means that since writer is an abstract class and it's compatible with anything that is a writer, that means it's also automatically compatible with file writer, print writer, and all the other things in the writer class. So basically, like making subclasses or child classes is a good way to make sure that class is compatible with the things that parent class is, and it just makes writing code like a lot simpler since you only need to account for that one parent class you want to deal with. That makes sense. And here we have a example of creating files. So I'm going to run this really fast, and I want you to pay attention to, and let me just screen share my example code file path, and you will see that I crucially only have two text files here, a COVID genome and a patient info text file. Here's the my folder file, which is currently empty, okay? So just take note of that. And I'm going to go back to my coding, my Eclipse, and I'm going to run this, okay? And as you can see, here I created a new file called example file.txt, another file.txt, and using this slash, I'm actually specifying a file path. So I'm specifying it is within my folder, and a Word file that is named another Word file.doc. And if you use .doc, you actually make, I think, a 2003 Microsoft Word document, or 1997, I don't remember, but that creates a Word file instead of a text one. And this, by using my file.create new file, I actually create an empty file within the file explorer, although this doesn't really matter because, as you can see, if you use a writer to write into a file object, it will automatically create that file within the file explorer, regardless of whether you call create new file or not. So here I'm using file writer, my writer, new file writer, and I'm passing in another file. So I'm telling the writer that that's where I want it to be written. Here I'm using print writer. I'm passing in my file, and I want to write another way to write ... And see, I'm doing close, which just closes the, I think it's called the stream. And you need to do this when you're using one of the writers. And buffer writer, it's a class that like wraps around another class, which means you need to pass in another writer class into it as a parameter. So new buffer writer passes in this file writer, new file writer, Word file. So I wanted to write in my Word document, and I want to write this as a Word doc, and then I want to close. So those are the three files I've created and write in. And by the way, you can actually use all three, like three different writers nested, such as new print writer, new buffer writer, new file writer, another example of text, and it's an example of it being very nested. So yeah, allow me to share with you my recently changed file directory. So you can see there's some new files. You'll have an example file, Word file, and another file in my folder. None of these files were there before, I just created them. And let's say I open this Word file, and I will share with you this Word file now that I just opened. And as you can see, it says this is a Word doc, and that's evidence that my writer worked because it wrote the words, this is a Word doc in my Word file. Or for another example, take this file right here, right? My example file that I wrote the words another way to write in. If I switch to that, it's there. Or if I switch to the file in this folder called another file, I wrote the words, this is a file inside it, and well, there was a file. So yeah, it's a demonstration that my way of writing things and creating files is working. Now let's look at reading files, which is very closely related thing, although it's a little bit more complicated, I believe. Reading files. So the easiest method to read files is use scanners, because I'm sure you guys are familiar with scanners. They're used to get input from the user, and usually when you're doing that, you would do scanner, new scanner system.in. But instead of putting system.in, you would put the name of a file because you want to scan the file and not the input given to the system or in the console. That's what the user typing. There's a lot of different ways to read text files. There's a whole list here, and there's so many other ones. You can find files in a directory with list files, which returns an array of files. So like if you have a file folder and you call list files on it, it returns all the files inside that folder. If you're looping through multiple file folders that are nested, you can use a recursive method or use a tool with the same function, such as Apache Commons file utils tool, in order to loop through numerous nested file folders. And I'm not going to go into this in this class, but if you look at this website, it's not very difficult to program. It requires a little bit of recursion, but it's a pretty simple program. You can just follow the instructions, or you can also just get file utils or some other tool that's available online. So if like me, you are handling a large database, a large collection of files, and they're all in nested folders, and you just want to sort through the files, you might need something like that. So tools for handling other file types can be found online. There's a lot of different file types, obviously, not just .text. Text files are the most commonly encountered, especially if you're trying to download, say a COVID genome data that someone might be analyzing. That's usually found in a text file. But there's a lot of other file types. As I mentioned over the summer, I had to deal with NII.gz files, which is a rare medical imaging file type, and I had to get a special tool in order to handle it. But yeah, if you have some weird file you need help handling, you can always email me, of course, and I'll try to find you a tool and send you a screenshot of me using it or whatever. But I don't expect too many people will have to deal with a really weird file type. And I'll just start talking and demonstrate this really fast. I should mention that this class is supposed to be 90 minutes long, but I'll also open up the questions or review in some time. However, you guys can leave whenever you need to. So here, and I'm just going to comment this out because I don't want it to necessarily run again. Okay. And this seems fine. So here I'm going to be reading the COVID genome text file. And this is the source of the data, by the way. What I downloaded is not the full COVID genome, obviously. It's just like the first 60 lines or so, just for the sake of demonstration. And basically what I want to do is I want to save this COVID genome sequence list into a array list, which we looked at earlier, in groups of 10. So I wrote a little while loop to do that. I can dissect this a little more if you want, but I'm sure you guys know how to read while loops. Basically, while my reader sees another line, it will save the next token, and token is basically a word for the sake of this presentation. If the token contains A, T, G, or C, basically if it's a legitimate DNA sequence and not the number at the end of each line, it's probably better if I just show you. As you can see, there's a number at the end of each line that's like a count, and I want to save each of these individual tokens into an array list. So I want to discard it if it's just a number. And the easiest way to do that, I mean, there's a lot of ways you can do that. You can verify if it's an integer using using java.math. But I'm just checking if it has one of the letters, and if it does, then it magically counts as not a number, and therefore I'll save it. Yeah, I'm just saving each of these individually into a array list. So it gets the token. It adds a token if it contains if it is a genome sequence. Otherwise, it deletes it, and it compiles like that, and then it will print out the toString and the size of this array list. So if you go over here, you can see an array list of the genome sequences, and if we check that, and it's 66 long, and we check that, it's accurate to what we saw here. So, yay! Here we have the next file reader example. I'm not going to go into this in as much detail just because it's a lot of the same thing. I use file reader, buffer reader, and string tokenizer, which are just these other tools, in order to read lines. So as you can see with string tokenizer, in order to read the file. So with string tokenizer, you just make a new string tokenizer, right, called st, and you pass in the next line that I read with the buffer reader, another reader. And a buffer reader, again, is similar to a buffer writer. You pass in another reader class into it, and it wraps around to make it faster. So buffer reader, another reader equals new buffer reader, new file reader. So you're passing in this file reader and patient info text. You're making a file reader that can read this patient info text file, and you pass into a buffer reader that wraps around it. And it's called another reader. And then you take the next line of another reader and you save it into the string tokenizer, which then tokenizes it. Basically, it splits it into words. Now, tokens are not necessarily words. I just call them that. Tokens are basically like chunks of strings, right? And they can be split by these things called delimiters. And usually delimiters are spaces, but you can split them into any other sequence or single character if you'd like. So you can see st.next token, st new string tokenizer, another reader read line, and that just means it is looking at the next line. And this is just some really specific code that's designed specifically to look through this file, which is my patient info file, and I'll just screen share that really fast. This is my patient info file, and it's designed specifically just to loop through it. It's going to discard this file and just save this string as the name. It's going to discard this token and then save this as the age in an integer, and then it's going to discard this. It's going to discard this token. It's going to set the comma space as a delimiter, so that way it does not save the comma into the token, and then it will save headache, cough, and nausea into the symptoms list. And once again, if you are looking at this later, or at home, right, you can see the specifics of how it's done. But yeah, right here is where I am changing the delimiter to split the tokens, to split the string into tokens, based on that, in a way that allows me to grab the symptoms. And then I'll make a array list of symptoms, right? And I will add all the tokens, which are all the chunks of strings, all the symptoms, right, into the symptoms list array list, and then I'll print it out. So you can see I gather the name and the age, and I'll print it out now. Evie, age 33, experiences the following symptoms, and I'll print out headache, cough, and nausea. And those are the things I've grabbed from that file. So if you have a lot of files that look like that, you can use a similar code and just run a loop through it and look through all of that. This one's just commented out. I'm not gonna bother doing this probably. Okay, so here's another fun one, okay? And this is looking at reading things in a directory, which I touched on earlier. So normally reading things, right, what did I just do? Okay, normally reading things, you would read a file, but what if you want to look through a directory? Like what if you have a whole list of files, right? Or if you just want to see how many files are inside this folder. And so in this case, you would want to have something that that allows you to look through the whole directory at once and just like automatically loops through it for you instead of making you do this manually. This is especially like a problem if the files aren't named this systematically, so you couldn't easily make a loop that goes through it in another manner. So you can see we have file my directory equals new file sample directory, and notice this is not the name of file, it is the name of the folder. That's why we don't have a .text or anything here, because it is a folder. It's a file folder, not a file. However, folders will be treated as files in the sense that they will be counted as files if you search through them with a directory. So yeah, here's an array of files. Dir files equals my directory.list files, and so the .list files function literally just makes a list of all the files that's within this directory. And I believe it will return null if it does not have any files inside it. I believe. And let's see. Oh no, the array will be okay. So it will return null if it does not denote a directory. So yeah, if it's not like a folder or anything, it will return null. Anyways, you can get to list files and you can save that into an array of files. And then for every file that's in that array, you can therefore create a new scanner that reads the file, and then you do whatever you want with the string. In my case, I am concatenating the string into this variable right here and saving it all into one variable. And then after I am done taking this first word from every single file in this directory and then putting it all together in one string, I can print that out and I'll get a rickroll. Because that's the words I saved into those files. If we take a look, right into any of my files, for example, example file A is just the word never, and example file B is just the word gonna, and so on, and all of it kind of just forms a rickroll. But obviously you can use it for more productive things. So for example, if you need to grab some kind of information from a source downloaded in a particular way, then you would need to use a directory search to find everything you need. So that finishes up with the file reading section. And finally, I'm going to touch a little bit on graphics, and then I'm just going to take specific questions because honestly, I don't think that Java is a good language for graphics. And I'll show you in a second. So graphics, you can do graphics in Java. I don't personally recommend it. I feel like Python is definitely better for graphics in that sense. You should use matplotlib if you want to make a graph. I don't think that Java graphics are fun to use. I don't think they're good, but I mean, you can use them. I'll just go over the really basics because if you really want to use them, the resources are right there. It's just a bit of a mess in my opinion. I don't really think anyone here is making like an amazing game with Java graphics. And I'll just open up my demo drawing.java. Okay, so my demo drawing is really basic. I don't know why I'm making a rectangle that looks like this, but it creates a color for my graphics board G. I don't know what I call the board, my graphics G. It fills an oval at this location, and it fills a rectangle for some reason. I don't know why it does that, but it fills an oval at this location. And then meanwhile here in my main, I have a frame that I call demo drawing. I have a canvas that I fit in the frame, a canvas, right? I set the size, I add the canvas to the frame, I pack the frame, which just sets its size correctly, like your window size correctly, and I make it visible. So let's just show you what that does. I don't know if you can see that, so let me just, this is what I just created. It's not the most beautiful piece of graphical design the world has seen, but it's something. I'll just show you really fast what happens if we don't have the frame.pack line. And as you can see, you just get this really tiny little window. And of course, not a big deal because you can just full screen it and you can still see it properly, but it is kind of a pain, right? I have no idea if that's displaying properly over Zoom, but it is still kind of a pain if you don't pack it. So that's why you use the pack function. And to set visible just makes it visible. These are all things. If you change the canvas size, you change the size of how big your drawing space is. Over here with the oval, you can, change the, I believe this is X, Y, width, and height of the oval. And here it's important to note that instead of doing like a 0, 0 on the bottom right, on the bottom left hand side, as you would expect, the Java 0, 0 is actually on the top left hand side of the coordinate plane. So you would have it like right here. So like if you start the oval at 0, 0, then the oval is actually going to move all the way up to the top left. And I'll just show really fast demonstrate that. Right, all the way up to the top left. And meanwhile, if I make this like a 100, 200 by 200 kind of deal, and I run this, I share it, it's gonna have moved to the right and down because this right here is 0, 0. That's the very basic of Java graphics. There's obviously more to it. And a lot of it has to do with like maybe writing a loop. One thing I think would be interesting to do with Java graphics is actually programming it to create a fractal, because fractals are really simple way of making complex graphics with just simple math. And I can demonstrate that like right now if you want me to attempt that, but I'm not necessarily sure if I can. But there's some things you can do. You can also like, as you can see, you can also do a lot of things. Once again, this helpful function on Eclipse just gives you a list of all the stuff a graphics can do. Something you can do is you can draw a polygon, and you can give it set up points, right? Draw it. One thing you do is draw an image. And there's a lot of different functions that allow you to draw an image. Right. I don't really have an image prepared for me to draw right now, so I'm not gonna do this, but like if I had an image saved, I would draw an image at that point. I don't know. There's a lot of stuff you can experiment with, right? G dot draw arc, and okay, let's just plug in some random numbers. 20, 100, all bits x, y, width, height, start angle, arc angle. So when I start angle, I don't know, 30, arc angle 120. And let's see what that creates. And as you can see here, I just created an arc, right? And if you look closely, right, it's red, it's right there. And if you look closely at the demo drawing, and you just hover your mouse over this, it will give you like a nice tooltip showing you exactly what all these parameters are supposed to be, and you know, what you need to do to edit that. So again, I don't really think that Java is really a great place to make graphics if you're trying to do something complex, but you definitely could render something cool, especially with the use of loops. I don't recommend drawing things by hand, just one by one. Yeah, you can make something cool. And that's kind of all I wanted to share regarding my PowerPoint presentation. I'm just going to go back really fast to the presentation. That is the, it just closed this. That's just basically what I have to talk about for today. And I just want to say, I did go through some things relatively quickly. And does anyone have like some specific questions or something specific they want me to go over again, or try to program in class? Or maybe a question regarding to their project that they're doing? Now is your time to ask. Let's see, how do I put chat? Oh, cool. I was just sent it Google Drive. Okay, cool. Oh, it's already saved there. That's really convenient. Oh, where to put it? I mean. Oh, right. Okay, yeah, makes sense. That's just PowerPoint. I will do that. Anyways, bye everyone. Thank you for hanging out, and make sure to email me if you have any questions.
Cool. Thanks, Helena, for recording.
And we'll just stop share, and let's see if